All right, guys, so we're going to look at X11 and 12. The first one being X11, independent and conditional probability. Okay, so in this case, for these, we're solving if A and B are independent events, what is the probability that A and B occur? Okay, so to make them independent, if you multiply the two together, you're going to find the answer. So it's going to be 1/5 times 3/5, 3/25. All right, so that's all we have to do for that one. So the probability that both A and B occur is going to be 3/25 if they're both independent. Okay, if they were not independent, this number would be different. It'd be smaller. All right, let's look at the next one. In experiment, the probability that event A occurs is 5/8. The probability that B occurs is 1/4. The probability that event A occurs, given that event B occurs, is 3/8. Are A and B independent events? Okay. So let's see, we got A, and we have B. Let's put those together, 5/32. That is not going to be equal to 3/8. So there's something that's dependent in that event. So these are going to be, that's going to be a no. All right, let's look at one more. Experiment, the probability of event A occurs is 4/5. Probability of B is 1/7. And the probability that event A occurs given that event B occurs is 4/5. Okay, are A and B events independent? So they're gonna kind of try to trick you because, okay, we got A 4/5, B 1/7, and A and B is gonna be 4/5. Okay, so you multiply these out. Yeah, we can do it that way, but also looking at A 4/5, A including B is gonna be 4/5. So these are actually gonna be independent here. Okay, because when they're both included together, 4/5 is the same as A, and then B is going to just multiply on top of that, so it's going to be a smaller number. So this one we can see based on the evidence right here, we got A and B is 4/5, and event A is 4/5 as well. So these are going to be independent. All right, moving on to the next section, we have find conditional probability using a two-way frequency table. Okay, so we've seen these plenty good amount of times. So looking at one here, Janice is a physical therapist who specializes in leg injuries. Her patients differ in age and type of injury. Okay, so what is the probability that a randomly selected patient is between 13 and 19 years old? So we have a category 13, 19 that goes across here, given that the patient suffers from knee pain. Okay, so if you have the two of them include, so if you look down here at the example, we'll just run through it. So this is the outcome of event A and B is 6. So it's going to be 13 and 19, and then knee pain as well. And then event B is going to be just the knee pain. Okay, so all we're going to have to do is add up the knee pain, which is going to be on the bottom, which is going to be 8. And on the top is going to be 6, which is going to be just this bottom number right there. So it's basically going to be 6 divided by 8 right there, so including both of them. All right, so then you reduce that down to 3/4 in that case. All right, so let's look at another one, pause the video and see if you can try it on your own. So I'll just read it out to start. Chef Khan baked his famous casseroles from a company holiday party. The casseroles had different shapes and different delicious fillings. That sounds good. What is the probability that a randomly selected casserole is filled with cheese, given the casserole is shaped like a rectangle? All right, so cheese and rectangles, that's that number right there. Again, I'll pause and see if you can figure this out. All right, so you should have found that AB included with B is going to be on top, which is going to include the cheese, and it's going to include the rectangle, which is just going to give you 2. All right, and then the bottom is going to be of rectangles. So the last thing they're asked is shape like a rectangle. That's going to be our B. And then cheese is going to be our A, but this one we're looking for cheese and casserole. It's going to be our top number, our numerator, and our denominator on the bottom is going to be 6, which is just going to be our rectangles added up. So 4 plus 2. All right, so then that's going to be 2, 6, which you're going to just reduce down to 1/3. Just make sure you reduce, so you don't want to get the answer incorrect. All right, we're going to do one more. Okay, sushi restaurant. So I'm just going to skip this first part. You can read that if you'd like. Probability that a randomly selected sushi roll contains salmon. Okay, we got our salmon row right here. Given the sushi roll is labeled not spicy. Okay, so salmon not spicy, that would just be 4. Oops, my tool here. So we have 4 on the top for not spicy salmon. So that's going to be A and B. And then given sushi roll is not spicy, so we're looking at all the not spicy. So we're going to be 9, 4 plus 3. Let's say it's going to be 13, 16. All right, so it's going to be 16. So that's event B. And that's going to reduce down to 1/4. All right, bam. There we go. Get to it. Thanks, guys.